Finish reading. Start solving. This exam is a question, okay? Anyone get answer? You need to support by equation. Any feedback? I write the equation. Sum of Qn equal sum of Q out. Maybe. Why? It's longest answer. You select the longest one. Someone check something for what you need. Okay. No one get answer. I see many get answer now. Okay. True, excellent. ID, yes. Yes. Internal diameter. Yes, I see here now some engineers get the correct answer. Yes, excellent. So be careful for this, please. And be careful for this. He play a lot for this in his exam. I tell you before last session. Feet and inch. So by the way, here sum Qn equals sum Q out. So how many input here? We have one input, two input, and one output. So Q1 plus Q2 equal Q3. So I mean here 1, 2, 3. So Q1 A1 V1 plus A2 V2 equal A3 V3. Correct. I see diameter and the velocity here, diameter and the velocity here, and diameter and the required what here? Velocity. So missing here is what? Velocity. How to get the velocity here? By this equation, AV plus AV equal AV. So all is given, remaining is 1. We can substitute and get the remaining now. Okay, how to get the missing now? A1, which is pi over 4. All areas, if we check, area is pi over 4 d square, correct? So this pi over 4 here, pi over 4 here, pi over 4 here. You need to write pi over 4 for all terms? No, we can cancel pi over 4, pi over 4, pi over 4. I will write it, don't forget that, and then cancel, okay? Pi over 4, d squared 1, v1, plus pi over 4, d2 squared, v2, equal pi over 4, d3 squared, v3. So cancel pi over 4 with pi over 4, pi over 4, remaining is diameter. So we can continue here in whiteboard here. d1 square, it means 10 divided by 12 to be feet. But I check with you something else, but this only here, okay, not all. What is this? Normally we shall, not should, shall change inch to feet, correct? It's a must to change inch to feet, correct? To be make balance for units. But here the same pi over 4 like this is all the same but cancel. So here d square, d square, d square, we have diameter in all term. Each term have diameter, and also all it is function of inch. So if I convert this one to feet, convert this one to feet, convert this one to feet, it means you divide on the same number, divided by 12, divided by 12, divided by 12. So the 12 square, 12 square, 12 square, it's also cancelled together. So in this case only, we can substitute as it is inch, which is means balance h is the same, sorry, inch, it is the same here as inch, is the same here as inch, because when I convert this one to feet, is the same conversion here. We can take common factor and they cancel together. You understand me? Because when you see with me also 12 squared, v1 is 1 feet per second, plus other one is 5 inch by 12 squared, multiply 10, which is equal to 12 by 12 squared, v3 required. So this 12, this one is cancelled with this one, is cancelled with this one. So 100 plus 25, 110 equal 144 v3. So v3 equal to this one plus this one divided by 144. This can be get at 2.4 feet per second. Also, you see, is mostly nearly. Many questions also coming like this. Most nearly. It means when you calculate, it is not yet 2.4 clear. You found 2.3 something, 2.4 something, 2.5 something. So the near value is 2.4. The near value is 2.4. But for this question, if you have any thing not clear, tell me please. Check and tell me if you have any question. No question?
Dr. Sami,
Yes.
uh, first I thought this continuity equation, is it only for the closed pipe or can be joined 2 or 3 pipes? I mean the inlets.
What you mean like this?
No, I just to try to get this continuity equation only applicable only like kind of closed pipe, or can be any 1 or 2 inlets for the pipe.
No, no, not close point like this. Something like this network. Here, vibe, all this input, and we have one output like this, like this, like this. If you study this as a total system, what I mean, where is the exactly control volume you study? If you study the total system, so what is the input for you? This one, this two, three, and this output. Clear? But if you study like this is the control volume for you. So this input and this output. Clear?
Got it.
You got it?
Yeah, got it. Thank you for that.
But the note to be aware for this, for all pipeline, same like this case, whatever we are working in pipeline, anything going in the pipe should be going outside. So first term all the time is neglect, which is what happened inside. No, anything going in should be going out, especially for pipeline. And this normally is the case coming in the exam. Okay, another equation. This is another famous equation coming, Bernoulli equation. This Bernoulli equation actually it is a formula for energy, but in ideal case. Means ideal case it is means no losses in this equation. No losses. No losses, no equipment inside like pumps, like turbine, nothing, only energy without any losses, ideal case. For this energy here, we have three types of energy for at any point, at any point. Maybe we can check point, it have two energy only. So one of the three, it's converted to another. Same like uh, uh, energy conversion, okay? So for Bernoulli equation, we have some consideration for this. What is consideration? It is apply along a streamline. Apply along a streamline. So if you have a streamline like this in the flow, so I can apply between this point and this point, point one, for example, and point two, for example. What said this Bernoulli equation? Said the energy at any point along the streamline, it is the same, constant. Which energy? Total energy for this point. So it is not flow energy, it's not potential energy, it's not kinetic energy alone, but the total energy package. The total energy, it is constant. So the total energy at point one, it is the same total energy at point two. Total. What is this type of the energy or consists of this energy? Three types: flow energy, potential energy, kinetic energy. But normally the problem coming in the exam, it's not solved by the energy form. What meaning of energy form? Energy form, it means each term for this equation with energy unit. Energy unit. But in the exam, normally we can solve it quickly by head form or pressure form. And the famous one is head form. What's the meaning of that? It is the same equivalent to the first case or first shape, first form, energy form, but the unit, it's not energy unit, it is head unit. Head unit is like meter, like this, okay? So like, for example, pump. When you describe a pump, you describe by flow rate and pressure, and sometimes you can describe by head, is the same. So I can tell you the pump is 20-meter head. What means 20-meter head? Head is referred to direct to the pressure. So energy equation, Bernoulli equation here, but also like this. We can represent the terms of energy. And instead of that, we can put a head, and this head is referred exactly same like energy. Okay, just to change unit, not more. So to change this form, first form for energy here, change this form to be in head form, we need each term, it is in unit of meters, like this, for example, this GZ, Z is length or elevation, which is meter, and G. So one of this, for example, you need to cancel G. So you need to divide all terms, each term here divided by G. So divided by G, we can get it Z divided by G, which we have G rho, which is OG is gamma, here gamma. Here divided by G is G. So we converted this one in from energy form to be in head form, but it represents the same thing. Okay. B over gamma plus Z, it means piezometric head. Piezometric head. Remember last session we studied three types of measurement devices: barometer, piezometer, and manometer. Piezometric head is coming or refer from piezometric or piezometer. Okay, same like this device. Measure static pressure. Measure static pressure or static head. Other term is v square over 2g. V square over 2g. This means velocity head, and also the same total head is equal to constant. Total is equal to constant. So piezometric head plus velocity head is equal to constant. We can write it in another thing like head h static plus h dynamic equal h total. We can write it like this. It's the same meaning. B over gamma plus z, which is referred to piezometric head, is referred to static head. And v square over 2g is referred to velocity head, which is referred to dynamic head. And this total is total energy or total head. Total head. This clear? Very important equation. Same like continue. We have another form for this. It's not used a lot, but it is the second one to be used. The first priority for main equation coming for in the head form, use the head form. Second one is pressure. Third one, and used rarely, the energy one, energy form. For the pressure form, so we need the pressure unit in each term. So we need the B, for example, alone. So we need to multiply all terms here, multiply each term with gamma, gamma, gamma here. So if you multiply this one, first one here, multiply by gamma, we can say gamma with gamma, so we can obtain B alone, plus. Here gamma multiply Z, which is gamma Z, plus. Here we are going to multiply gamma, and we have in the denominator G. So gamma is rho G, cancel G with G, so we can obtain rho G square over 2, equal also constant, the same constant. And this means piezometric pressure, this means piezometric head, and this total, sorry, piezometric pressure, dynamic pressure, okay, and this total pressure. Let's see one important equation, one important problem from the exam also applied for Bernoulli equation. The Bernoulli equation is based on the assumption that
there is no loss of energy of the liquid.
there is no losses of energy of the liquid zone. We get some answer here. Okay.
All the above.
Now I have another is all of the above. Here you are. We are complete between and D. Okay. Okay, actually the correct answer is D. D, all of the above. All is accepted. All is assumption for Bernoulli equation. Okay.
I have one doubt, Mr. Sami. I don't agree with this answer.
Which one?
I have one doubt. How come velocity of the flow is uniform?
Actually, if you check the equation here, you will find B over gamma plus Z plus V square over 2G equal to constant. Okay.
Okay.
Here, velocity, it is a scalar value. Okay. If you check the pipeline, the velocity, if it is not uniform, it's not like this. You can't give this one or represented by one value. So if it is not ideal, it is real like this. So the velocity here is not constant.
You mean
Not
to say
uniform, not uniform. So in this case, we need to calculate equivalent velocity, which is mean if I need to calculate equivalent velocity like this to represent this one, what is the equivalent for this one? Should we make integration for this one and so on? Correct? To obtain what? To obtain uniform velocity, to obtain one value, I can put it here. So this one, it represents scalar value, one value. For the Bernoulli equation, actually, the velocity, it is considered as a uniform velocity.
okay.
For real one, we put the V bar, which is average velocity for this one. We put also something is called alpha, which is a correction factor for the velocity and so on. Okay. Euler's equation. This Euler's equation is also coming to study a relation between a pressure, but normally not with velocity. We study with more advanced, it's more difficult Euler's equation. So I just write here information about this one. I don't go in details for the equation related to it. It's not easy to solve. Used to study pressure variations. Pressure variations. So, for example, if you have a truck and this truck is moved, okay, if this truck is moved, what he required, for example, here, just he required some information about what is the pressure at the end point here, what's the pressure here at this point, what is the pressure here at this point, which one is the maximum pressure during the tanker is moving, what's the maximum pressure if this is going to be deaccelerated with acceleration, blah, blah, blah. All here is affected by a vector, not scalar like Bernoulli, okay? It's the Newtonian law of motion applied to fluid particle for inviscid and incompressible flow. Inviscid and incompressible flow. Static pressure, it's the pressure of flowing fluid at any point. This is static pressure. Same like what is the device used for that? Piezometric pressure. Piezometric pressure. Pressure tape, it is a small hole in the pipe. Small hole in the pipe. This pressure tape. This is the equation I tell you. Just read carefully first. I give you 1 minute to read it. Then we're going to solve. Finish reading. And if you have any suggestions for the solving, tell me please. Finish reading. Okay. First equation. Why these two pipes have different phasing of the electron? One of this pipe is raised by 2 inch, another one is raised by 12 inch. Okay.
Due to difference,
What you mean by different velocity and what you mean by different pressure?
yeah, due to difference in pressure.
Again?
Due to difference in pressure at the center and at the corners.
No. For the level, consider both is measure the same point here. For example, this point 1, this point 2. It means almost near together. 1, 2.
No, but point 2, where you have got the pitot tube inserted in the mid center of the pipe, it's taking the velocity or the pressure from the center of the pipe, isn't it? Whereas point 1 is only at the corner of the pipe, where due to the resistance of the powder surface, literally there is a very less velocity or less pressure.
For the surface?
Yeah, at the surface due to the friction between the
Where is surface?
pipes.
I tell you no, both measure the same point. This one, this two. This pipe measure 1. This pipe.
No, it is measured in the 2-inch one is on the surface of the pipe. The other is in the center of the pipe.
You see like this, but it's measure pressure here.
Okay, but it's saying that the water, the liquid is stagnant in the border in the head of the
No.
Yeah, the flow in is stagnant at the head of a very fine bore tube.
Yeah, but this pipe is measure this point. This pipe, it is intersect to measure this point. You remember piezometer? You remember piezometric? Piezometer device, which is just one thin pipe like this on the cylinder or whatever to measure the pressure inside, static pressure, just going to raise. What is this raising? Due to difference between atmospheric and the pressure inside. So this represents the pressure inside.
Yeah, it's a pitot tube, isn't it? Yeah. Okay.
The region is different. No, we don't have different diameters. This is the same diameter used to measure 6 inch. For the diameter for the small pipe, no, not effect. Just this like small, very small effect. What else?
Reason is the head 12 inch is sum of velocity head plus static head, and 2 inch is only static head.
Which one is static?
2 inch is only static,
Uh-huh.
and inch is velocity head plus static, just like in fan flow.
But why is this one number two? Why number two is measure static plus velocity head?
Because it is facing flow.
Freezing flow,
Yes,
freezing at point 2.
yes.
Yes. This is the close answer to correct. This is the correct answer actually. Actually, for the pipe, for the 2-inch pipe, 2-inch height, this only measure static head. Same like the figure for piezometer. So this flow is moving inside the duct, 6-inch duct. The flow is moving, and I don't know, I don't affect on this flow. I don't stop anything. Still, the velocity is moving, not a change. So the part of dynamic not a change. So in this case, the raising here is referred to directly static, only static. This for what? For this one, for this pipe here. Is measure what? Only static, because the flow is not affected with anything. Kinetic energy is the same, have a value. So this represents static. But for another pipe here, for point 2, in this pipe, the flow, it's not moving down here. Then like the engineer mentioned, it's freezing, stagnant. He mentioned here it's stagnant here. And what's meaning of stagnant? It means the kinetic energy here lost. But the energy is not lost, converted from one shape to another. So the velocity here, velocity at this point, which is going to be 0, is totally converted from this shape to another shape. Represented which shape? Once it stopped, it's represented in the pipe by height. So the part of dynamic here, it's represented as a head of. But be careful. Careful for what? What you mean 12-inch? This refers to the part of dynamic? Not all. Why? Because actually this point, it is have two energies. Pressure energy and kinetic energy. So the part of dynamic is converted to head. Where is the part of static? Is represented also in head. Same like the first one, 2-inch. So the 12-inch is include both velocity part, velocity head and pressure head. So pressure head, velocity head, static, it means static plus dynamic. Yes. What is static plus dynamic? Refer to what?
Constant.
Constant, which is referred to total. So this one is static plus dynamic equal to total, H2. And this one is referred to H static. Clear now? So we have H total, H static plus H dynamic plus equal 12 inch. And we have H static equal 20. Why other one represents for static only? Because the flow is still moving, not effect on the velocity, still moving for first case. Okay, what is the required? Required the flow rate in the pipe. Required what? Flow rate in the pipe, which is means Q. Flow rate is Q. Is most nearly, means we will found the answer is near to the correct answer. So the flow rate in the pipe is most nearly what? Q is equal AV. Correct. And if you check here, we will find the Q is equal AV equal pi over 4 d square V. And d square is equal what? 6 inch. So is equal pi over 4. 6 inch, which is 6 divided by 12 square V. So what is missing here? Velocity. How to get velocity? For sure, from another given here. Head, what's the real head? The exact equation, if you remember, P over gamma plus Z plus V square over 2G equal constant. So this part is barometric head, barometric head. So which one is represent barometric head? Static. So this one is static. H static. And this one is what? This H dynamic. And this one is what? This H2. So the velocity here, which is required, is including inside H dynamic. So I need to get H dynamic. It is easy. This is static plus dynamic. This is static. So if you need dynamic, just substitute from this one to this one. So you can get from these two equations, H dynamic equal 10 inch. 10 inch. 12 minus 2. That's it. So we have what? We have H dynamic bar. And this H dynamic is equal to V square over 2G. So I can write here H dynamic equal V square over 2G, which is equal to 10 inch. Here, okay. To continue from this equation, the velocity equal root what? 2G multiply 10 inch, which is 10 divided by 12. Now is P. What is G? What is G? Can you tell me what is G, engineers? What is G?
9.81.
You lost. You lost the mark for this question. Why? Here, this bridge, one of the values, trust me, is better to remind. Save it, please. G. G 9.81 this meter per second square, but actually it's 32.2 feet per second square. So I can write here equal root 2 multiply 32.2 multiply 10 by 12 to get down. Kindly check quickly. If you have any question, tell me. I'm going to calculate the velocity.
Dr. Sami, why 10 by 12? Because H dynamic is
Inches.
10, right?
From inch to feet. Because G
Okay.
is feet square per second. Feet per second square. Yes, feet. Problem not finished actually. After you get the velocity should be multiplied by over 4 this square here, this one, this part here. This is the last step. Don't forget. Just multiply the velocity, you get it, multiply by over 4 6 over 12 to change the inch feet square. This what? This area times the velocity you get the flow rate most energy. So start by 1 by 1. 2 multiply 7.32. Velocity is 7.32. And this velocity should be multiplied by over 4 v square, v6 by 12, half square. So we can multiply bracket 25 square plus the bracket okay, multiply by divided by 1.4 1.44 cubic feet per second. So the Q here 1.44 cubic feet per second. 1.44 cubic feet per second. Again 1.44 cubic feet per second. That's it. Any question? Any question? No question?
This the problem that you solved. Can we when you update this in the today's session, will there be a workout for this? Because now I'm not able to follow actually whatever this. It's all over scattered all over the screen. I lost in the middle actually.
You lost in the middle?
Lost in the middle.
Sunera?
Okay, can we please get a clean workout of this if you don't mind, Dr. Sami?
The problem which is solved, whatever this from the equation you solved, right? That the whole solving, if that can be put it in separately, it will be easy for us to understand.
No problem.
Because this was scattered all over the screen. I lost completely actually.
Yeah, no problem for me. I just try to solve it on the same problem to see the equation itself. That's it. But no problem for me to solve it outside. No problem. This is the problem, correct?
Yeah.
So here this refers to what? H static. And this refers to what? H total is referred to H static plus H dynamic. Correct? So H static plus H dynamic equal 12 inch. H static alone equal to inch. So from these two equations, you can get H dynamic equal 12 inch minus 2 inch equal 10 inch. Okay, continue. Any question? Yeah. Okay. So this H dynamic, but I know the original equation, which is P over gamma plus Z plus V square over 2G equal constant. What is this part? This is static. What is this part? This is dynamic. This is static. This is dynamic. This is total. So I get what? I get dynamic. And you need what? You need velocity. So make equivalent, which is 10 inch, is equal to what? v square over 2g. So v square over 2g equal 10 inch. G should be said 32.2 feet per second square. From this equation, you can get what? Velocity. Velocity is equal root 2 multiply 32.2 multiply 10 over 12 to change it from feet to inch. This what? This G. This what? This to change it from inch to feet. From here, you can get velocity, which is equal to 7.3. What is the required? Required at the beginning here, Q, flow rate. So Q is equal AV. What is A? Pi over 4 D square V. So pi over 4 D here is 6 inch diameter of the duct. So 6 divided by 12 square multiply velocity, which is getting here, feet per second, multiply 7.32. Then you can get the answer 1.44 feet per second square. This clear? Is good now?
Yeah.
Any
Yeah, it's
question?
clear. It's clear.
Clear now?
Thank you.
Welcome. Any more question? Okay. I go to close this one. Back to the presentation. Okay. Just to check this problem, give me answer. Tell me what you see. Check question 4. Okay. Formula. Wait. Okay. Anyone get answer? No one get answer? Oh, we have 3 in the chat. What's central pressure? Okay, I tell you, no problem. Okay, before I solve, I tell you something. Don't read the question. Don't see the figure. Check answer again and give me answer. It's not a crazy. Trust me. Maybe you change your mind. If anyone change your mind, I see different answer now. It's good. I'm happy for this. Okay. Actually, when you read the question, you feel it's difficult. The my question was center pressure. Logic question. Before I going in details for the question, and I give you some information about the figure and the name of the required. Just if you check the choices here, you can get the answer without reading for anything. You see, actually these two terms, and we have a plus in between. So plus it means shall be, must be, all terms the same unit. This term the same unit for this term, the same unit for this term. No way. So by easy way, just I going to check what? I just going to check units for each term. Check units and tell me answer please. Maybe you are change your mind. Any more answer? No more answer. Okay. Yeah, yeah. Yes. Only B has the same sum of the same units. And when you found two terms the same units, now we need to read the questions. But before that, no need for anything. Just this difficult question, difficult equations I found. So just going to check this first. Okay. If uh, only one accepted, so shows this the answer. Okay. So here x bar distance as if you check here figure, x bar is distance, p is distance, d is distance. So this one is cube, it means meter cube, and this one only one, it means meter cube and meter, not accepted. This here for number p, d square and the x bar, which is meter and the meter square, we can cancel meter with square, it's remaining meter for this term, and this meter also. So this meter and this meter, which is accepted. Here is squared and without any square, so it's not accepted. Meter square and the meter not accepted. Next one also the same, square and without square. So the correct answer here without anything just is B. What is more to discuss here? I tell you small things. First, G is the center of gravity for the body. As you know, any body under or submerged like this, it applied with a force externally from the liquid, statically, from the static. If this one is static, not moving, we have a pressure is coming from the liquid. And as you know, when you're going down, the pressure is increased or decreased? Pressure increased. When you're going down, pressure increased. So it's logic. It's the pressure is applied on this plate. It is not the same because the height, it is not the same. The height here is not the same. We have here height. We have here different height. So the height here along the plate not the same. This is higher pressure, this is low pressure. If you check like something like this. So the pressure here is not the same. This is high pressure, this is low pressure. So it means the pressure here is not uniform. So the meaning of not non-uniform, if the Shape uniform. If I tell you what is the equivalent for this one, you tell me in the middle. This is the equivalent force. But if it's not uniform, so the equivalent for this one not in the middle. As you see here, the higher pressure is down, so it's by default the equivalent pressure or force due to pressure is sure below the middle, below the center. So somewhere here, this what this is the equivalent pressure or force due to pressure. This is the equivalent force due to pressure. Acting in one point like this, what is this acting point? It's called center of pressure. Center of pressure. So the center of pressure, this is the line of action for the applied of equivalent force due to pressure, along with this one. X bar is the distance from the centroid of the body to the surface. B and D is the dimension of the body itself. The distance from the center of pressure to the surface is what? This is the distance required. Distance of its center of pressure from the water surface. This is the required. He needs this distance. What is this distance actually? This distance is equal to x bar, which is referred from the distance from centroid to above, plus this part, this small area, this small distance, which is referred for this one, d square over 12 x bar. Coming from where? From equation of center of pressure. I don't need to solve to save any equation like this, but just I write it to be aware. Y equal x bar, y center of pressure is equal x bar plus I divided by x bar over A. A is area for this body, B times D. X bar and I is the second moment of inertia, and this you can get it from tables. It's constant. For a square have value for I, for rectangle and different value for I, for circle, for quarters, for semicircle and so on. Each one is have the equation for this one. Okay. For example, if we need to check for the square one, I think is 12 bh cube over 12. Yes. I for this shape, for example, for rectangle, d cube b over 12. If you substitute this one here and the area BD, we cancel B with B, D cube cancel the one of this with D, remaining D square over 12. D square over 12 multiply x bar plus x bar plus x bar. I don't need to save anything from this, just what I need. We solve this one by simple concept, balance of the units, units. Second thing, I need for you to be understand this information about for the pressure distribution along with the body, static pressure here applied on any body submerged to be known. And remember, the pressure up is lower than the pressure down. And this is the reason, for example, to build the dam like this. Why we build the dam is sent from up and take from down due to the same concept for that. The same concept, because the pressure when going down is increased. So this one is built like this, and this one is 10, no need for to be checked. Okay. Center of pressure is below the centroid because it is not a uniform, it's not in the center. This is just information I need to save it. This equation I don't need from you to save it. Just I write it to be a complete picture for this information. That's it. Okay. So if you have any question, tell me. No question? Okay. Okay, I start for numbers first. I'm going to take after that. We have some numbers. It is important to be aware. We study here some numbers in fluid mechanics, and we study some numbers in heat transfer. This not more numbers I will get bring here, but this is the important numbers coming in the exam. First one, real number, is coming theoretical and numerical questions. For numerical, we apply for one question in last session in the exam one, last question. Here for reduced number as a definition is very important because it is slightly similar with another one we will see after 2 slides. What is the definition for reduced number? Reduced number, it is equal to inertia force divided by viscous force. It is a ratio between inertia to viscous force. Inertia force to viscous force. Inertia force to viscous force. Please be careful for this definition. It's close with another one, conflict with another one we will see. Inertia by viscous force. Okay. What is units? Any numbers normally without units. Reduced number. Once you see something number, normally we bring it by scientists without to be dimensionless. We use it by dimensionless. Okay. Also, I give you before, maybe I think last session, the ranges of reduced number. Reduced number less than 2,300 is laminar. Between 2,300 to 4,000 is transient. More than 4,000 is turbulent. Just take two, less than and more than. In between is transient. Okay. What is the equation for reduced number? Rho v d over mu. Rho v d over mu. But the famous one used in the exam and coming a lot with different shapes. Rho sorry. Vd over mu. This is the famous one. Okay, not this one. This reduced number. Other number is Mach number. Mach number, it is a dimensionless also quantity, is a ratio of flow velocity past the boundary to the local speed of the sound. In another way, Mach number is equal to the speed of the flow, divided by the speed of sound in this flow, because the speed of sound changes according to the type of the flow. So this is the speed of sound in the flow itself. This is the Mach number. Mach number may be equal to 1 or less than 1 or more than 1. Mach number equal to 1, it means is sonic flow. If it is less than 1, is subsonic flow. If it is more than 1, is supersonic flow. Supersonic flow is used for jet engine. Okay. And if the Mach number increases more than 3 or 4, it is a hypersonic flow. Broad number. This is a number I tell you it is close from the definition of reduced number. Broad number, it is dimensionless value also and is a ratio between inertia force to gravitational force. And this one is described different flow regimes of open channel. Describe different flow regime of open channel flow. What is the definition of broad number? Ratio of inertia force by gravitational force. Other one, inertia force by viscous. Here, inertia by gravitational. You see broad number, maybe some engineering, it's not here about broad number, and also me too, but it's coming for me in the exam. Okay, this one is very important actually. Okay, broad number. The other information, just I bring it to be if you need to read more about broad number, but actually what's coming in the exam, only definition. Inertia force to gravitational force. What I expect is to ask for the question numerical should be give the equation. It's not give. It seems like we should be given the equation to just statistic. Okay, this broad number. Okay, let's take a break. Going to the break first, 5-10 minutes maximum, and we come back again. Okay. Any question before we going to the break? Any question before going to break? Okay, everything clear? Okay, this is good.
हेलो। बिजी हो गए क्या? अच्छा, खाना खा रहे हो? अच्छा, खा बाद में। हाँ ना, मैं अभी 10 बजे तक बिजी रहूँगा, बाद में करता हूँ आपको 10 बजे के बाद। हाँ हाँ हाँ।
अभी जो आज बहुत ही ज्यादा चौंका देने वाली एक रिपोर्ट आई है इंटरनेशनल मॉनेटरी फंड की, IMF की, जो अंतर्राष्ट्रीय संस्था है और फाइनेंस जगत में सबसे बड़ी संस्थाओं में एक है। उसका कहना है कि भारत की जो पर कैपिटा GDP इनकम है उसको बांग्लादेश पीछे छोड़ने वाला है। बांग्लादेश अब बहुत जल्दी भारत की पर कैपिटा GDP इनकम से आगे निकल जाएगा। मतलब भारत के जो आर्थिक हालात है वो बांग्लादेश से पिछड़ते हुए दिख रहे हैं। ये किसी और ने नहीं कहा है बल्कि IMF ने कहा है। राहुल गांधी जी ने इस पर ट्वीट भी किया है, प्रशांत भूषण साहब ने भी ट्वीट किया है, ग्राफ भी इसका दिखाया है, जो पूरा प्रोजेक्शन है। लेकिन ये कितना चिंता का विषय है इसकी आप कल्पना नहीं कर सकते। और यही हुआ है जब मोदी जी की सरकार ने 6 साल से नफरतों के काम किए तो हम आर्थिक मोर्चे में पिछड़ते चले गए। फाइनेंशियल एक्सप्रेस ने खबर छापी है, मैं हिंदी के अंदर आपको दिखाता हूँ। भारत को प्रति व्यक्ति GDP में पीछे छोड़ देगा बांग्लादेश। 1991 के बाद सबसे बुरे दौर में भारतीय अर्थव्यवस्था, ये कहना है IMF की रिपोर्ट का। आप सोच सकते हैं कि आप कल्पना कर सकते हैं क्या हालत हो गई है हमारी, क्या हम किस जगह पे आके खड़े हो गए। और गांधी जी ने ट्वीट भी किया है, ट्वीट अंग्रेजी में है, देख लीजिए, हिंदी का अनुवाद इसका यह है, बीजेपी के घृणा से भरे सांस्कृतिक राष्ट्रवाद की मजबूत उपलब्धि, बांग्लादेश भारत से आगे निकला। आप खुद देख लीजिए कि क्या हालत कर दी आज देश की। नीचे पूरा का पूरा राहुल गांधी जी ने एक चार्ट भी लगाया है, जिस चार्ट को IMF ने जारी किया। इसमें साफ बताया गया है कि बांग्लादेश अब पीछे छोड़ देगा भारत को आर्थिक मोर्चे पे, पर कैपिटा GDP इनकम में। कुछ चीजें इसके लिए महत्वपूर्ण है, ये समझनी होगी कि हम कहाँ पर आके खड़े हुए हैं, कौन इसका जिम्मेदार है। इसकी जिम्मेदारी थी जिस बांग्लादेश को हमने बनाया इंदिरा गांधी जी के समय पर, जिस बांग्लादेश को बनाने वाला भारत हो, मतलब भारत उसका देश हो, भारत उससे बहुत पुराना देश हो, भारत का ये हिस्सा था बांग्लादेश। तो बांग्लादेश बाद में देश बना, भारत की वजह से बना। वो बांग्लादेश हमको अब इकोनॉमिक मोर्चे के ऊपर, आर्थिक मोर्चे के पीछे छोड़ के आगे निकल गया। लेकिन जिम्मेदारी किसकी है, कोई सवाल करने को तैयार नहीं। तो लोग कहते थे कि मोदी सरकार में आने के बाद भारत अंतर्राष्ट्रीय स्तर पर और तरक्कियां करेगा। तो इनसे जाके पूछे कि क्या हालत कर दिया, 50-60 साल पीछे चले गए हम। 50-60 साल पीछे ले गई है सरकार भारत देश को, जो अंतर्राष्ट्रीय स्तर पर विश्व गुरु बनने की राह पे था और लगभग बन चुका था। मनमोहन सिंह जी के जमाने में हमारी तुलना होती थी चाइना से, होती थी US से, होती थी अमेरिका से, होती थी इन बड़े देशों से हमारी तुलना होती थी। और आज ये बनता गया 6 साल की बीजेपी सरकार में कि हमारी तुलना बांग्लादेश से हो रही, हमारी तुलना जहाँ पर बड़े बड़े देशों से होती थी आज हमारी तुलना बांग्लादेश से हो रही है। तो कौन जिम्मेदार है उसका, किसकी इकोनॉमिक पॉलिसीज है जिन्होंने बर्बादी भारत के लिए लाके खड़ी कर दी। क्योंकि ये लगे जब राजनीति साधने के लिए, अपनी राजनीति करने के लिए, क्या आज भी कोई सवाल नहीं कर सकता। आपको बताइए कि पर कैपिटा इनकम में इतना पीछे हो जाएंगे, मतलब हमारे देश के अंदर क्या गरीबी बढ़ रही है, क्या हमारा देश पिछड़ते जा रहा है। और सिर्फ यही नहीं है दोस्तों, जो लोग अभी इसके ऊपर बातें करेंगे कि नहीं हर तरफ तरक्की हो रही है, थोड़ा सा मामला यहाँ पर है, ये बहुत बड़ा विषय है। IMF ने रिपोर्ट जारी करके कहा है कि बांग्लादेश भारत को ओवरटेक करने वाला है पर कैपिटा GDP में। इसका मतलब समझते हैं क्या, इसका मतलब साफ साफ ये है कि हमने हमारी आर्थिक बदहाली की तरफ कदम तेजी से बढ़ाना शुरू कर दी है। ये 6 साल की मोदी सरकार ने हमें किस जगह पे लाके खड़ा कर दिया, आप समझ सकते हैं। सिर्फ पर कैपिटा GDP इनकम की बात नहीं है दोस्तों, इन्होंने क्या क्या नाम रोशन किया है आपको देख लीजिए। प्रशांत भूषण जी ने तो एक ट्वीट भी किया और उस ट्वीट में इन्होंने यही लिखा, इसको पूरे के पूरा जो IMF का रिपोर्ट है और उसका जो ग्राफ है उसको डालकर उन्होंने लिखा कि और कितना बड़ा अचीवमेंट चाहिए। बेशक ये बहुत बड़ा अचीवमेंट है, नो डाउट ह्यूज अचीवमेंट, क्योंकि अनभक्तों को तो यही लगेगा कि ये भी अचीवमेंट है। अनभक्तों से सवाल कीजिए कि सिर्फ ये जो IMF की रिपोर्ट है यही पहली चीज नहीं है। जो बेरोजगारी 14 करोड़ लोगों को बेरोजगार कर दिया, इसमें भी हमने सारे देशों को पीछे छोड़ दिया। कोरोना के अंदर तबाही मच गई जिन देशों में, उनमें से टॉप 3 देशों में और अब टॉप 2 देशों के अंदर हम एक है। सबसे ज्यादा जिस देश ने अपने लोगों को खोया कोरोना के अंदर और सबसे ज्यादा जिस देश में लोग संक्रमित हुए वो हम है। कौन जिम्मेदार है, कोई सवाल नहीं कर सकता। इकोनॉमी को तबाह बर्बाद कर दिया। तो तेजी से अगर किसी देशों की इकोनॉमी बर्बाद हुई है तो उन देशों में हम भी एक है। और ये सब कब हुआ है, जब सत्ता के अंदर बीजेपी की सरकार है। आपको बताइए कि हैप्पीनेस इंडेक्स जो एक पूरे के पूरा खुशी मापती है अंतर्राष्ट्रीय स्तर पर हर देश की, हैप्पीनेस इंडेक्स के अंदर मतलब लोग कितने उदास हैं हमारे देश में, अंतर्राष्ट्रीय स्तर पर हम पिछड़ते चले गए। हैप्पीनेस इंडेक्स के अंदर हमारा पायदान नीचे गिरता चला गया है, मतलब साफ है कि लोग खुश तक नहीं है। ऐसे ही हंगर इंडेक्स में हमारा नंबर बढ़ता चला जा रहा है। सबसे ज्यादा अगर भूखे लोग किसी दुनिया के अंदर देशों तो भी मिसाल एक है, इसका हर निर्देश नहीं पड़ता, इसका असर आम लोगों को पड़ता है, आम नागरिक को पड़ता है, आम इंसान की जेब में पड़ता है, आम बहुत जिम्मेदार था। आज सिर्फ पर कैपिटा इनकम जीडीपी पर कैपिटा जीडीपी का पिछड़ों दिखाया है कि हम बांग्लादेश जैसे देश से पीछे हो गए। ये सिर्फ एक ही चीज नहीं है, बल्कि इसके बहुत सारे बैकग्राउंड है, इसका बहुत बड़ा बैकग्राउंड है, इसकी बहुत सारी चीजें जिम्मेदार है। तो ये बीजेपी सरकार ने कमजोर किया है, आप खुद देख लीजिए। जीएसटी को लाके थोप दिया गलत गलत तरीके से, बिना किसी तैयारी के। आज व्यापार तो खत्म हो ही गया जीएसटी की वजह से। तो मनमोहन सिंह जी का जीएसटी था पूरी तैयारी के साथ करना, उसको गलत तरीके से थोपना, लोगों के ऊपर व्यापार बनता है और साथ के साथ अब पूरे राज्य जो है परेशान हो गया। राज्य को कंपनसेशन करना था और अब मोदी सरकार कह रही है उधार दे दीजिए, कर्जा दे दीजिए, हम नहीं देंगे। जो लिखित एग्रीमेंट किया था केंद्र सरकार राज्य सरकारों के बीच में कि पैसा देंगे आपको जीएसटी के जो नुकसान होगा उसका, आज साफ मना कर दिया है कि नहीं देंगे, आप अपना कर्जा दीजिए। उसके साथ साथ के साथ तो आप देख ही रहे हैं दोस्तों, पूरे देश में आंदोलन है। कुछ चल उद्योगपतियों की खातिर किसानों की बलि चढ़ाई जा रही है। किसानों की ये बदहाली का जिम्मेदार कौन है?
Okay, let's start. Yes, great, correct. It is C. Excellent. Let's continue. Okay, the correct answer is D, inertia. A flow in which inertia force is dominated over the viscosity is called turbulent flow. Intensive and extensive property, we have one question maybe in the exam one, we will see this one. I don't remember intensive or extensive, but by the way, it's coming in the exam sometimes extensive property, sometimes intensive. Extensive property, it is the properties that depend on the mass. But intensive property, it is a property doesn't depend on the mass. Okay. Next, please.
Sorry to interrupt. I have one doubt. Kindly go to last slide. Yeah. Intensive property you have written, it is not depend on mass, but density is mass by volume, right?
But what?
The definition of intensive property is written as property doesn't depend on mass.
Yes.
But density is mass by volume, right?
But it does not depend on the mass. Yes, it is mass by volume, but it does not depend on the mass itself. This is what he mean here, density and specific volume. Both, it is not dependent on the mass. It's a function of mass. It is one of the parameter is mass, but not dependent on the mass itself. It's a property, not dependent on the mass.
Okay.
The volume only is dependent on the mass. What's the answer here? Ideal fluid. Yes, ideal fluid. Okay. Excellent. Four stages. Next. Yes, excellent. Correct. One of the property not studied before, the surface tension. What is surface tension? Surface tension, the symbol for this one is sigma. It's the material property which a liquid at a material's interface is a liquid at a material interface. This normally it is happen between liquid and the gas exerts a force per unit length. What I mean, for any liquid, the molecules on the surface create forces in the surface. Okay, these forces created contact together between these molecules create surface. This is called surface of the fluid. Surface of the fluid, and this surface have a value is called surface tension. Measure the we can measure what we can set the interaction between molecules to be more strong, not more strong, something like this. Why is this created? To cover any attack from outside between, for example, if you put one pipe, very small pipe, you will see some of this liquid is going inside, raised up. This is not due to pressure. The effect of the pressure here, it's neglect. Actually, the main effect here, it is due to surface tension. Because you cut the surface of the liquid, it's found and create force applied in other directions called surface tension force. Surface tension force, and this the raising up for this height according to this due to surface tension. Okay. By the way, don't go in details. Surface tension here is a function for property. It's a function for the force with length. Same like viscosity, it's a function for shear stress with velocity gradient. Here, this surface tension is equal to force due to surface tension, the force exerts here, per unit length, per unit length. We have two applications, famous application. Sometimes it's coming to ask for these two. The pressure, internal pressure, the internal pressure created in the droplet or hollow spherical droplet due to the surface tension. If you have droplet like liquid droplet, sorry, liquid droplet like this. The internal pressure here, the internal pressure here inside to keep this in the shape for droplet is equal to 2 sigma over r. 2 sigma over r. And in other side here, a hollow spherical droplet, the pressure inside is equal to 4 sigma over r. For example, something like this here. If I cut like this hollow, it means air here. This air, not liquid. It's air. But is this inside is total liquid. The spherical droplet, the pressure inside here, from where is this coming? Is this coming from the balance between the internal pressure and the surface tension of the shape? So the pressure here is equal to sigma over r for the first one. But for the spherical one, hollow spherical one, it is double for the droplet. Why is double? Actually, this coming is double because in the spherical hollow, have two surface tension, external surface tension and internal surface tension, external surface tension and internal surface tension. But in the droplet, only we have one surface tension. So the first one is 2 sigma over r, second one is 4 sigma over r. These two phenomena, cohesion and adhesion, what's different between cohesion and adhesion? Cohesion actually, it is the interaction between same molecules. Interaction between same molecules. This coming due to attraction force between molecules and the same one. But adhesion, it is the attraction force coming between two different subjects, two different substances. Like same like this one here is H2O with another thing. Okay, but if this molecule is H2O with another molecule is H2O, this cohesion. Okay. See next this one. Can you solve it, please? Okay, all agree for the answer. This cohesion, correct. Let's see next one. We have a different confusion here between many things. Actually, he talked about for the end, this is due to property. So it's asked for property. Cohesion and adhesion is a phenomenon happening inside this umbrella for this property, but the property itself is surface tension. So the answer is C, surface tension. Next, please. Okay.